In an interaction diagram, I start by making a sketch of a system. In this case, I'll have a horse pulling some sort of a wagon. And I've labeled a few of the things that are involved: our horse, our wagon, the ground, and the earth. So it's important we start with a sketch of our system. Now I want to look at how these systems interact with each other. I'm going to count the horse as one object, the wagon is another object, the ground is an object, and then finally the earth. So first I'm going to list my non-contact forces. In this case, we're really only talking about gravity. Let me go ahead, and there's an attractive force between the horse and the earth. I'll put a little G here. Okay, between the wagon and the earth, I'll put a G there. Okay, and the ground itself is attracted to the earth. And okay, I think that's about it. Notice as I put these interactions, I'm only drawing in a line between the two objects that are involved. I don't have any arrows at this point because forces act between two objects, and I'm just identifying the two forces or the two objects that are involved. Now I'm going to list my contact forces, and those are the forces that are involved with actually two objects touching. First, let me go through with tension. As I look in the system, the one matter of tension I can see is between the hitch of the wagon and the horse. There's a tension force. Okay. Now let's take a look at normal forces. Normal forces are those that keep two objects from passing through each other. We have between the horse and the ground, between the wagon and the ground, and I think that's about it. Maybe the ground and the earth. There's a reason that the ground itself doesn't go sinking into the earth. Taking care of those. Now you'll notice each of those I've ended up putting an N to indicate it's a normal force. And the last one, friction. That's the force that prevents two objects or resists two objects from sliding past each other. Again, between the horse and the ground, we'll have a frictional force. And probably between the wagon and the ground, we'll end up having a frictional force as well. Now, I'm interested in making a force diagram for the wagon. So what I'll do is I'll enclose the wagon, and that'll help me define the forces that I'm involved with. Okay. So I have my enclosure. I can see that the forces that passed through that enclosure, I've got gravity, I have a normal force, a frictional force, and a tension force. Now remember, for each of these forces, they are Newton's third law force pairs. It may seem odd, but that it does seem normal to us that the wagon is being pulled down by the Earth's gravity, but the Earth is also being pulled up by the wagon's gravity. Wagon is being pulled down, Earth is being pulled up. We don't notice it so much on that the Earth moves just because the Earth is so large compared to the wagon. Likewise, that the wagon wheels are pressing on the ground, which also means that the ground is pressing on the wagon's wheels. The wheels are pushing down on the ground is pushing up on the wagon wheels. So I want to make a force diagram for the wagon. So I'll end up reducing the wagon down to a single dot. And then as I go around, I'll have to describe or provide an arrow for each of the forces. Okay. First one I see is gravity. So gravity is going to be a force that acts down. So I'll note that as being the force of gravity. Something we haven't done so much is add these additional modifiers. I use the F to indicate that I have a force. The G indicates that it's the force of gravity. The next letter I'm going to use is identify what the force is acting on, and that would be the wagon, so I'll put a W for that. And then I'm going to end up describing what it is that's acting on the wagon. In this case, it's the earth. That's the source of the gravity. Okay. Let's go around a little bit further. We next see that there's a normal force. But a normal force is acting upward on the wheel. If it wasn't there, it would end up falling to the center of the earth. So I'll put a note that it's a force. What type of force? I'll use N for normal force. Again, it's acting on the wagon. Okay, and what's the source of that? I've ended up calling it the ground. I want to indicate that both up and down are of equal magnitude, so I'll use a little slash mark to indicate that. Okay. In this situation, we'll assume that our horse and wagon are moving either at a constant velocity, I guess that makes sense, constant velocity, or standing still. I think the constant velocity makes more sense. Okay. Let's go ahead around here. We see that there's a frictional force. Okay. If we assume that velocity is to the right, okay, we know that friction will be acting to the left. So I'll have a frictional force, F for friction, and there's small f that it's a frictional force. What is it acting on? The wagon, so I use a W. And where it's the source of that friction, again, is the ground. Okay. The last thing we have here is a tension force. That's going to be acting to the right. So again, I have a force of tension this time. Okay, and what's it acting on? Again, the wagon. And what's the source of that? Is the horse. Because our forces are balanced, because I made the statement we're at constant velocity, the force to the left is equal to in magnitude in the opposite direction to our force to the right. If I had a weight or perhaps the mass of this object, I could end up giving this a value. Let's say it was 100 kilograms. I would know that the force due to gravity would be 1,000 newtons. Just want to show you one other item in here. If I were to draw a force diagram for the horse, okay, again, I could end up enclosing the horse. In this case, I would have the force of gravity on the horse from the earth. Okay. I have a frictional force, and what's interesting is a frictional force is actually going to be forward. I could think of it this way. If there was no friction, what would happen? The horse could not move forward. So it's a frictional force that moves the horse forward. Again, I have a normal force. Force normal on the horse from the ground. And the last item we're going to look at is this tension force here. The tension force from the horse is being pulled back. So I know it's this direction. It's going to be a force. Okay, it's let's see, a tension force. In this case, it's acting on the horse from the wagon. Notice that over here we have the force tension on the wagon by the horse. This one we have the force of tension on the horse by the wagon. And we know that these two are equal because according to Newton, forces, let's see, for every action, there's an equal and opposite reaction. We can identify these two forces, this force here and this force here, as a Newton third law force pair. And if we just want to add a few more items, we know that because the horse is at constant velocity, if there was nothing else pulling him back besides the harness on the wagon, that the force forward would have to be equal to the force backward. Our normal force would be equal to in magnitude in the opposite direction from gravity.